In this video, we are going to use Math Help 13 to solve for where this 6-inch radius and this line at 1.48 diameter, where they intersect, in order that we can put a Conrad in here of 63 thousandths. That saves us from calculating where the end of the 6-inch radius is, where this little radius starts and ends, and where its center is. So let's begin here. Let's start a cycle beginning at x and y 0. Let's take 40 thousandths per pass, rough it along the z-axis at 450 surface speed for roughing, with 10 thousandths, or 8 thousandths, I'm sorry, IPR, inches per rev, tool 1. Here on the finish cut, our question mark's up, so press help, and it asks if you'd like to have a separate Z cut. What you can do is, like, you could leave maybe 10 thousandths on diameter and say 3.5 on shoulders. We don't really need that for what we're doing in this demonstration, so I'm just going to remove that finish cut, the separate cut for Z. Let's finish at 500 surface speed for our finishing cut, 5 thousandths per rev, and here we could call out a separate tool for finishing. So we could use maybe tool 1 for roughing and tool 2 for finishing. For our purposes, I'm just going to tell it tool number 1 for roughing and finishing. We're just cutting air and it cuts pretty good. I'll hide this for a second. So what we need to solve for is where this 6-inch radius and this 1.48 diameter intersect right here. And we can do that with Math Help 13. Let's do a cycle arc move. The direction of this arc, this is this first section of arc, is clockwise. That's number 1. So type a 1 and then set. Now, to solve for the endpoints, which is out here, we'll use Math Help 13. So press the help key now. And we want to go to line arc intersection. Number 13, which is find the intersection of a line and arc when 2 points are known on the line, which we know 2 points down here on the line. We can pick any 2 points on this line, so long as they're at inch 480 diameter. It could be any 2 points, it doesn't matter what they are. Any 2 points at 1.48 diameter will give us this straight line. And we know the arc, center, and radius. So if we look at this, here's 0 right here. It's a 6-inch radius, so the center in X is going to be at 0, and in Z it's going to be at minus 6 inches, and the radius is going to be 6. So we have all of that information. Now look at our picture. We can see here it's asking for X1, Z1 is the first 2 units it needs. So just look at your picture and you can see that X1, Z1 would be a point on the line. So that's 1.48 diameter in X, and we could say maybe a 1/2 inch in Z. The Z value is really not important. X2, Z2, that's the second point on the line. Well, it's at 1.48. Those are the 2 important dimensions. This constructs a straight line at the 1.48 diameter. These 2 numbers just define its length. We could say the second point is Z0. Now, X3, Z3, we can see here on our diagram, is the center of the radius. So X would be at 0 and Z would be at minus 6 inches. And the radius itself is 6. And there's your solution. What we're going to do here is say load that as the end. It just popped those over into our program, and when we press mode, it takes us over and we can see those values are in here. So that's a 6-inch radius, and at the end of this arc, there's a 63 thousandths Conrad. So 0.063, and if you push the ink set key, you'll get a Conrad. Then we have a turn move. We're going back 625. So X is not changing, and we're going minus 0.625 in Z. Yep.